So I want you to just take a second and imagine your absolute worst nightmare of a workday.
Oh, boy. Oh, all right, I'm picturing it.
Okay, so picture yourself sitting in this windowless cubicle, right? And your job for the next 8 hours is just to log into a piece of software, click a drop-down menu, select an option, and take a screenshot.
That sounds miserable already.
Right. But wait, it gets worse. Then you have to print that screenshot on actual physical paper, punch 3 holes in it, and stick it into this massive white binder.
Wow.
Yeah, and you do this just to prove that the drop-down menu works, and the kicker is tomorrow, you're going to come in and do the exact same thing again to prove the menu still works. Have you ever been trapped doing something like that mind-numbing just to generate a piece of paper that says, yep, the button still clicks?
I mean, that sounds less like a job and more like some sort of modern mythological punishment, like Sisyphus, but with office supplies.
Exactly. It sounds totally absurd to most of us. But if you talk to validation engineers in software, especially in these really highly regulated industries like pharmaceuticals or aerospace or medical devices, that scenario isn't some hypothetical nightmare.
Right. It's just their reality.
Yeah, that's just Tuesday for them. It's their daily, inescapable reality. And so for this deep dive, we're really zeroing in on why that reality is finally starting to crack.
Thank goodness for that.
Seriously. We're looking at this really fascinating piece by Omar Seaman from Validfor, and it's titled Automated Testing and Validation. Can AI replace manual scripts?
It's just such a crucial question to explore right now, I think, because, we see AI being pitched as the magic bullet for literally everything these days.
Oh, totally. Like from writing emails to driving our cars.
Exactly. But the world of highly regulated software validation is incredibly unique.
Yeah.
The stakes are they're incredibly high.
Right. And our mission today is to sort of slice right through that typical tech hype. We want to separate the grand promises from the actual ground-level reality when it comes to using AI in these incredibly strict environments.
Which is so needed right now.
Yeah. But to do that, we first have to understand why the industry became so obsessed with, physical binders and printed screenshots in the first place.
Yeah, to really appreciate what Simon is addressing in this Validfor piece, you have to look back at the historical context of computerized system validation, or CSV.
CSV, right.
Yeah, so go back a couple of decades. Software was just starting to control things that could literally mean life or death. I mean, we're talking infusion pumps in hospitals, dosing calculators, pacemakers.
Because you really, really do not want a glitch.
Exactly. So regulators, like the FDA, were understandably terrified of software bugs. So they demanded absolute, undeniable proof that every single feature of a system functioned flawlessly.
And their version of undeniable proof was basically just a human signature on a piece of paper, right?
Pretty much, yeah. The operating mantra for years was essentially, if a human didn't physically test it and sign off on it, it is not validated.
Which created this massive physical footprint. I mean, when you hear software validation today, you probably envision like sleek data centers and glowing lines of code.
Yeah, something very futuristic.
But the physical result of that old human-only mindset was literal libraries. Just rooms stuffed to the ceiling with binders, reams of paper proving that a human being sat there, typed in a password, saw the welcome screen, and didn't notice any glitches.
It's wild to think about, honestly.
Yeah.
But this leads us to why AI is becoming so necessary. Because that old method of manual testing and, manual scripting is just fundamentally broken today.
Okay, let's unpack this, because there are a few core bottlenecks with manual testing that the Validfor article highlights, and I think the most obvious one is just speed.
Oh, absolutely. The time it takes is staggering.
Right, like executing a full regression suite manually, which basically means checking every single older part of a software system to ensure a brand new update didn't accidentally break anything. That can take weeks of human labor.
Weeks where the software just sits in limbo, just waiting to be cleared for use. And during those weeks, you're relying on humans who are, let's face it, susceptible to intense fatigue.
Right.
I mean, if you sit a person down for 8 hours a day to just click through menus, their eyes are going to glaze over. They'll lose focus, and they will inevitably miss small details.
But the real killer, the structural flaw the source really emphasizes, isn't just that humans get tired. It's that manual test scripts themselves are incredibly brittle.
Yes. Brittle is the perfect word to describe the architecture of these older tests.
I was trying to visualize this, and I thought about it kind of like this. Imagine I draw you a highly detailed, incredibly precise treasure map.
Okay, I'm with you.
I map out every single step perfectly right. Walk exactly 50 paces past the red stop sign, turn left at the large oak tree, dig 2 feet under the flat gray rock. It's a great map.
Sounds foolproof.
But what happens if the city comes by and replaces that red stop sign with a green one? Or, someone chops down the oak tree and plants a pine tree instead?
Oh, then I'm completely lost.
Exactly. Suddenly, my perfectly good map is totally useless to you. You're just standing there frozen, unable to proceed because the exact parameters I gave you no longer exist in reality. That is exactly what a brittle software test script is like.
That's a great way to frame it. And the Validfor piece gives this fantastic, highly technical example of just how brittle we are talking about here.
Yeah, the pixel thing, right?
Yeah, so older scripts and basic automation tools, they look for exact coordinates or specific lines of underlying code. If a user interface changes even slightly, say a developer tweaks the design and a button on the screen moves just 2 pixels to the left, an older manual script is done.
Just 2 pixels.
2 pixels. A basic screenshot test from yesterday is immediately rendered obsolete.
A human eye wouldn't even register that the button had moved. Like, I wouldn't notice.
Right, we would just click it anyway. But the strict manual validation process, or even a traditional record and playback bot,
Yeah.
it just says, the screen is different now, the exact coordinate is empty, the test fails.
Wow.
And then the engineer is forced to go back, halt everything, and rewrite the entire script from scratch just to account for a meaningless 2-pixel shift.
Which throws you right back into those weeks of delay we talked about. It's this vicious cycle of, like, writing scripts, the software updates slightly, the scripts break, and then you're rewriting them all over again.
Exactly. This raises an important question, though. If traditional automation tools are just as blind and brittle as your treasure map analogy suggests, if they just blindly click empty space when a button moves, what is modern AI actually doing differently to solve this?
This is where we get into the actual mechanics of the solution. Because the article explains that AI doesn't just record actions like a macro, it actually understands context.
Which is a huge...
Massive. The source outlines 3 specific capabilities that AI brings to the table to fix this broken system: self-healing, visual validation, and data generation.
Let's break down that first one, self-healing scripts, because this completely changes the paradigm. This is where AI moves well beyond just blindly following coordinates.
Right.
In the past, automated scripts use strict locators, like an XPath or a specific CSS ID, to find a button. So if a developer changed the background code, maybe they renamed the login box's ID from user ID 01 to just username, the traditional script just crashes.
Because it's looking for user ID 01 and it can't find it. It's standing where the oak tree used to be, basically totally lost.
Exactly. But an AI bot uses machine learning models to analyze the entire document object model, or DOM tree, of the page. It isn't just looking for one rigid string of text.
Okay, so what does it look for instead?
Well, it assigns a probability score to all the elements on the screen based on their proximity, their visual tags, and their historical function.
Ah, I see.
So when the ID changes, the AI looks around and says, okay, user ID 01 is gone, but hey, there's a new box here labeled username. It's in the exact same location, it's right next to the password field, and it accepts text. There's a 99% probability this is the box I need.
And it just automatically adapts? Like it just clicks the new box and keeps the test running?
It does. It dynamically locates the new element, updates the script's internal mapping, and just proceeds. It drastically reduces the hours engineers spend doing maintenance on broken scripts.
Okay, I have to play skeptic for a second here because that sounds a little concerning to me.
How so?
Well, if the AI is just calculating probabilities and essentially guessing where the button went, isn't it potentially masking a real software error? Like, what if the developer actually broke something crucial in the background, but the AI just aggressively clicks around until it finds a workaround?
Oh, giving them a false sense of security.
Yeah. It feels like it could tell the engineers the software is fine when it's actually broken.
That's a really sharp distinction to make, and it gets right to the heart of what AI in validation is actually designed to do. The AI isn't fixing or masking the software's underlying code. It's only healing the test script's ability to interact with the software.
Okay, so it's just keeping the tester alive, not fixing the patient.
Precisely. If the actual function of that login box was genuinely broken, like, let's say you typed in the password and the system couldn't connect to the database to verify it, the test would absolutely still fail and it would flag the error.
Right, because the action didn't complete.
Exactly. The self-healing mechanism just prevents the test from crashing purely because of a cosmetic name change or a 2-pixel shift. It ensures the test actually runs to completion so it can evaluate the real critical functionality rather than tripping over its own shoelaces before it even gets to the starting line.
Okay, that makes a lot of sense. It clears away the false alarms caused by minor tweaks so you can actually find the real fires. And that concept leads right into the second AI capability from the source, which is visual validation.
Right.
Because sometimes the background code is perfectly fine, but the actual screen layout looks like a total mess to the user.
What's fascinating here is that this is where computer vision steps in.
Hmm.
AI utilizes a concept called a golden master image.
The Golden Master, I love that. It sounds like some ancient artifact you'd find in an Indiana Jones movie.
It really does. But in this context, the golden master is essentially the perfect, approved baseline image of what the software should look like when it renders on screen.
Okay.
The AI takes the live screen it's currently testing and overlays it against this golden master, analyzing the structural layout, literally pixel by pixel.
And the source gives a really brilliant example of why this beats human testing every time. Imagine a mobile app for a medical device, and there's a crucial legal disclaimer text at the very bottom of the screen.
Oh yeah, the cutoff text example.
Right. Due to some weird screen resolution glitch, the last three words of the disclaimer are slightly cut off.
Now, a human tester, especially one who's been staring at screens for 8 straight hours, is highly likely to just click accept and completely miss the fact that the text is cut off.
Why is that, though? Just tiredness.
Partly fatigue, but also because the human brain naturally fills in the blanks. We know what that sentence is supposed to say, so our brains actually see the complete sentence, even if our physical eyes don't.
We're basically too smart for our own good in that scenario.
We really are. But in AI, it doesn't have human fatigue, and it doesn't make assumptions based on context clues. It just compares the structural rendering. It instantly flags that the pixels don't match the golden master, catching a subtle UI error that would slip right past a tired human.
That's incredible. And then there's the third capability, data generation. This is where we talk about the sheer scale of what AI can do.
The scaling is unbelievable.
We mentioned earlier how slow human testers are. Let's say you need to test how a new hospital database handles patient inputs. A human sitting at a keyboard might be able to manually type in, 20 or 30 test profiles in an hour? Like names, dates of birth, penicillin allergies, medication doses.
Which barely scratches the surface of what that system will actually face in the real world.
Exactly.
Yeah.
But an AI can generate thousands of synthetic, highly unique data inputs in seconds. And more importantly, it can intentionally generate edge cases.
The weird stuff.
Yes. It can create patient profiles with leap year birth dates, or last names that are 255 characters long, or completely contradictory medication combinations. It stress tests the system with weird data that a human tester simply wouldn't have the time or even the imagination to type out manually.
It's basically the difference between testing the structural integrity of a new bridge by having 3 people casually walk across it versus testing it by simulating an entire traffic jam of loaded freight trucks hitting it simultaneously. You find the breaking points much, much faster.
Okay, so we've established that AI is incredibly powerful here. It heals its own broken scripts, it uses computer vision to catch pixel-level rendering errors, and it generates massive amounts of synthetic data.
Right.
If it's doing all of this, why does the Validfor piece definitively state that AI cannot fully replace manual scripts?
That comes down to what the industry calls the 80-20 split.
Yeah.
The article makes a really compelling case that AI is perfectly suited to handle about 80% of the testing workload.
Okay, 80%.
And that 80% consists entirely of the heavy lifting, the repetitive, highly predictable tasks.
The stuff that causes the human fatigue we talked about earlier.
Yes. For example, regression testing, which we mentioned, running all the old tests to make sure a new update didn't break existing features. AI is perfect for that. It's also perfect for smoke testing.
Which is a term I absolutely love. Smoke testing is basically like kicking the tires and turning the key in the ignition of a car, right?
Yeah, pretty much.
Like, you aren't checking if the radio gets good reception or if the AC blows cold. You just need to know if the engine actually turns over before you spend all day working on it. In software, it's checking if the basic login and save functions work immediately after a new deployment.
That's a perfect analogy. And finally, AI handles load testing, simulating those 10,000 users hitting the hospital database all at once to see if the servers crash. AI is built for that 80% because it's objective, it's scalable, and it doesn't require any feeling.
Here's where it gets really interesting, though. We have to look at the remaining 20%. This is the domain where, according to the source, humans are entirely irreplaceable.
Yeah. The 20% consists of tasks that require inherently human traits:
Yep.
curiosity, empathy, and judgment. The first major area here is exploratory testing.
What does that look like in practice?
Well, this isn't following a script or comparing pixels to a golden master. This is a human sitting down, using their intuition to actively try and break the system in totally unpredictable ways.
Like a user clicking submit form and then immediately mashing the back button 3 times while the cage is still loading, just to see if the database duplicates the entry.
Exactly. And AI only tests within the parameters it's given. It doesn't get curious. It doesn't sit there and wonder, what happens if I do this weird, completely illogical sequence of actions?
The second human-exclusive domain the article points out is UX validation, or user experience, basically determining if a software workflow is confusing or annoying.
Right.
An AI can easily verify that clicking next successfully takes you to page 2. But an AI cannot tell you that the layout of page 2 is deeply frustrating to navigate.
And frustration is a key metric. AI lacks frustration, and it lacks intuition. Think about a nurse using software at hour 11 of a 12-hour shift.
Oh man, they have zero patience for bad design.
Exactly. Only a human tester can feel that friction and say, look, technically this software functions perfectly, but in the real world, our stressed out users are going to hate this interface, and it's actually going to cause them to make mistakes.
That is so true. And the final piece of that irreplaceable 20% is complex, subjective decision-making. The article specifically mentions scenarios requiring clinical judgment.
Which is huge in the medical field.
Right, because those situations simply cannot be codified into strict pass-fail criteria. Like if you're validating software that provides diagnostic suggestions to doctors, there are a lot of gray areas.
Right. It's not just true or false.
A seasoned medical professional needs to look at the system's output and say, okay, the code executed perfectly, but clinically, this dosage recommendation doesn't actually make sense for this specific patient profile.
So you end up with this really beautiful harmony. The AI takes the 80% of the mind-numbing, repetitive grind, and that frees up the human validation engineers to apply their intuition, their critical thinking, and their clinical judgment to the 20% that actually requires a human brain.
I love that division of labor. It makes perfect logical sense. But let's bring reality crashing back in for a minute. It's great that AI can do the 80% of the boring work. But does any of this even matter if the strict regulatory bodies reject the technology?
The regulators.
Right. We established earlier that the FDA demanded physical binders full of screenshots because they were utterly terrified of bugs. Wouldn't a massive, historically cautious regulatory body absolutely hate the idea of autonomous bots testing critical medical software?
That is the assumption a lot of people in the industry still operate under. The culture of binders full of screenshots is really hard to shake. But the Validfor piece reveals a surprisingly progressive truth about the current regulatory landscape.
Really?
Yeah. The FDA doesn't hate this. In fact, the FDA actually encourages automated testing tools under their new CSA guidance.
Wait, really? What's CSA?
It stands for Computer Software Assurance. The FDA looked at the industry and realized that companies were spending like 80% of their time documenting tests purely for the sake of compliance, and only 20% of their time actually testing the software for safety.
So the paperwork was actually stifling quality assurance.
Exactly. So the new CSA guidance actively pushes the industry away from that old, paper-heavy, screenshot-obsessed model. They want companies focusing on critical thinking, and they actively encourage using automated tools to do the heavy lifting.
So the regulators are totally fine with AI handling the regression testing.
They are, but there is one major non-negotiable caveat here. If we connect this to the bigger picture, the FDA's rule is that you must validate the automation tool itself first.
Oh, I see.
Yeah, you have to prove that the AI bot testing your software is, in fact, working correctly and reliably. You can't just unleash an untested black box AI on your pacemaker software and call it a day.
So you have to test the tester. You have to prove the AI isn't hallucinating or skipping steps.
Precisely. But once you establish and document that the AI tool is valid and trustworthy, the FDA views an automated test result as just as valid as a human signature.
Wow.
And arguably, it's more reliable. Because, as we established with the Golden Master example earlier, an AI doesn't get tired and miss a cutoff legal disclaimer.
So what does this all mean for the industry at large? We started this deep dive asking a pretty straightforward question based on Omer Sayman's article. Can AI replace manual scripts?
And the conclusion is a resounding yes for 80% of the repetitive work, but a hard no for the 20% that requires a human pulse, curiosity, and clinical judgment.
But it's the final takeaway from Validfor that I honestly find most compelling. AI will not replace validation engineers, but engineers who use AI will replace those who don't.
It represents a profound shift in what is actually valued.
Yeah.
The worth of a validation engineer is no longer measured by their stamina, like how many screenshots they can print and punch holes into.
Right.
Their value is now measured by their ability to leverage these AI tools to design smart automated strategies and to apply their critical thinking to ensure software is genuinely safe and user-friendly.
It's a fantastic reminder for you, the listener, regardless of what industry you're in. Whether you work in pharmaceuticals, software development, finance, or really any field that's currently facing massive information overload and an endless list of repetitive tasks.
Which is almost every field right now.
Exactly. AI isn't here to replace your human judgment. It's here to handle the Sisyphus-level grind. It takes the repetitive burden off your plate so that you can focus your limited energy on high-value, creative, critical thinking.
It's ultimately about elevating the human role, getting us out of the weeds so we can actually look at the whole garden.
Absolutely. But before we wrap up today, I want to leave you with a somewhat provocative thought to mull over, something that builds on that FDA requirement we just talked about.
Okay, I'm intrigued.
So the rule is that before you can use an automated AI tool to validate your software, you must test the tester. You have to validate the automation tool itself to prove it's trustworthy.
Right. You need a human to establish that initial chain of trust.
But think about where we are heading technologically. What happens in the near future when software systems become so incredibly complex and AI models become so vast that human beings physically cannot validate the automation tool anymore?
Oh, wow.
Right? What happens when the tester is too complex for a human to understand? Do we have to build a second AI to validate the first AI that's doing the validating?
Wow.
Does it just become this endless recursive loop of bots checking bots checking bots? And if we reach a point where no human can fully comprehend the entirety of the testing ecosystem, whose physical signature actually goes on the final approval?
That is a fascinating dilemma.
Yeah.
At what point does the chain of trust extend completely beyond human oversight, and how do regulators even handle that?
It really makes you wonder. 50 years from now, are we going to look back at our digital systems and find virtual libraries stuffed full of virtual binders generated by bots, just waiting for a human to try and make sense of it all? Next time you're stuck in a repetitive loop at work, just remember, you are the 20%. Use your intuition.
Yeah.
Thanks for joining us on this deep dive.